Hey guys, how you doing? Welcome to your first blended day. Today we're just going to try and watch a very short video and then we'll get you started on application of some of these vocab words. All right, so we're going to focus on Boyle's, Charles's, and Gay-Lussac's problems. Let's go ahead and scroll up here. For Boyle's law, Charles' law, and Gay-Lussac's law, what I really want to focus on is the relationship as well as the formula. So the definition of Boyle's law, we'll just keep it pretty straightforward. So it's just showing the relationship between pressure of a gas and volume of a gas. Relationship between pressure and volume. Moving forward, we're just going to call pressure P and volume V. Those are our variables. For Charles's law, we're going to call that the relationship between volume, again V, and temperature. Charles was a hot air balloon enthusiast, so you can see how this equation helps him do his thing. When we do temperature, anything with temperature and gas laws in here, we always have to be in a unit called Kelvin. It is a little bit different than Celsius. You just add 273 to your Celsius number. And then the final one, Gay-Lussac's law. Gay-Lussac's, we are looking at the relationship between pressure and, what do you think? Pressure and temperature. And again, we need to be in Kelvin when that happens. Again, T and P. All right, so we have these three units, P, V, and T. Looking at the relationship between these things, this is going to be an inverse relationship. So what that means is if you have like a syringe and you add, it's sealed up, you add pressure to it, so you push on it, what's happening to the volume of the gas? You know, and if I let go, what happens to the volume of the gas? So it's pretty straightforward. As you add pressure, the volume decreases. As you release pressure, the volume increases. And that is on a sealed container, or it could be a balloon. The formula is P1 times V1 equals P2 times V2. We will work a lot with that in the next couple days. Charles' law and Gay-Lussac's law, these are both direct relationships. When you think about them, so let's say you have this syringe and it's sealed up. For Charles' law, if I then took a lighter or something and I heated it up, and I heated it up and I heated it up, the volume of this thing is going to increase. You're moving those gas particles quicker, the volume increases. Gay-Lussac's law, same thing. You heat up something, heat up something, heat up something, the pressure is really going to build. Formula for Charles' law is V1 over T1 equals V2 over T2. Again, we'll talk about this in the future. And then P1 T1, P2 T2. So what I would like you guys to do for the rest of class today, we're going to go ahead and use these relationships, really the variables in pink. And you're going to open the document that's right below this video and just read, and pick out your variables. Look at your variables. Here we're talking about millimeters of mercury. Those are pressure readings. Here we're talking about 12 liters, right? That is a volume reading. So what law relates volume and pressure? What law relates volume and pressure? And so we are looking at Boyle's law. So this is, right now, this is just a Google Doc for you guys. I don't want you to write on this thing at all. On the back of this piece of paper, it's nice and blank. Just label 1 through 12. There are 12 of them, 1 through 12, and just write. Like, oh, look, we're looking at Boyle's law for number 1. Read number 2. Pick out your variables. What 2 variables are in your problem? Based on the 2 variables in your problem, go ahead and label it with whose law you're looking at, and we'll revisit this tomorrow. Good luck on your 12 problems, guys. Have a great day.